Good morning. Good morning, everyone. Today we are going to learn an important topic in pharmaceutical analysis and chemistry, determination of acid value and saponification value. This topic helps us understand the quality, purity, fats, and oils and waxes used in pharmaceuticals. Next one, introduction. Fats and oils are widely used in formulation to ensure the quality. We analyze them using specific parameter. Two important parameter are acid value and saponification value. First one, synonym, neutralization number and acid value. Definition, the number of milligram potassium hydroxide you required to complete neutralize freeze fatty oil, 1 gram of fats and oils. And following apparatus used in the experiment: beaker, conical flask, burette, pipette, etc. Chemicals: 0.1 molar 1 normality oxalic acid, potassium hydroxide solution, phenolphthalein indicator, and facts or oils used as a sample. Next one, this principle acid value determined by direct titration by oil and fact alcoholic medium against standard potassium hydrochloric or standard potassium hydrochloride or sodium hydrochloride solution. Procedure: standardize normality of potassium hydroxide solution, potassium hydroxide. 10 ml of 0.1 normality oxalic acid is poured with conical flask. 2 or 3 drops phenolphthalein indicator is added to the solution. The solution titrate with 0.1 normality potassium hydroxide solution till a permanent pink color appears. The picture shows the color changes. Next one, determination of acid value of fats and oils. Weigh accurately 5 gram of a sample, transfer into a conical flask, add 25 ml of 90% ethanol, mix the mixture very well, add few drops of phenolphthalein indicator and titrate it with 0.1 normality potassium hydroxide solution. Calculation: acid value equal to volume of potassium hydroxide in ml into normality of potassium hydroxide into 56 divided by weight of oil in grams, where V is equal to volume in ml of standard potassium hydroxide, N equal to normality of potassium hydroxide, W equal to weight in gram of the sample. These are the calculation for determination of acid value of fats and oils. I am repeated another time. Weigh accurately 5 gram of sample fats or oils. Transfer into a conical flask. Add 20 ml of 90% ethanol. Mix the mixture very well. Add few drops of phenolphthalein indicator and titrate it with 0.1 normality potassium hydroxide solution. On the acid value, the following formula used to calculate: acid value equal to volume of potassium hydroxide in ml into normality of potassium hydroxide into 56 and weight of oil in grams, where V equal to volume of ml of standard potassium hydroxide, N equal to normality of potassium hydroxide, W equal to weight in gram of sample. Next one, find the acid value using sample. Those 7 ml of required 3.8 ml of normality of potassium during titration. The calculation shown in the picture result. The acid value are given some. This is the model of calculation of acid value determination. Next one, significance. The value is measured of the amount of free acids which have been liberated by hydrolysis from glycerides due to the action of moisture and temperature. Therefore, oil with increased acid number unsafe for human consumption. Indicate the degree of randomicity of the facts. Next one, saponification. What is saponification? The hydrolysis of oil or fat with sodium hydroxide or potassium hydroxide to give glycerol and sodium or potassium salt of acid like soaps. This process making soap is called saponification. Saponification is nothing but making soap is called as saponification by using hydrolysis of oil or fat with sodium hydroxide or potassium hydroxide to give glycerol and sodium or potassium salt of acid. So the following equation show the preparation of soap. Next one. Next one, this is an experiment to determine the saponification value of oil or fats. Definition: the number of milligram potassium hydroxide required to saponify 1 gram of fats and oil. Saponification number is measured of average molecular weight of the fats and fatty acid in present samples: soybean oil, cottonseed oil, coconut oil, butter fat, and then the other side showing the saponification value of the oils. Apparatus: conical flask, 100 ml beaker, dropper, reflex condenser, water bath, pipette, 25 ml, and burette. Chemicals: ethanolic potassium hydroxide 0.5 normality, hydrochloric acid, phenolphthalein indicator. Principle: the saponification value of oils and fat determined by the reflexing an accurate weight amount of oil or fat and excess of alcoholic potassium hydroxide solution. Then titrate using potassium hydroxide agonized standard solution of the acid phenolphthalein as an indicator. Next one, procedure. Standardization of 0.5 normality of potassium hydroxide solution. Pipette out 20 ml of 0.1 molarity hydrochloric acid into a conical flask. Dilute with 50 ml of water and add 0.1 ml of phenolphthalein solution. Titrate with ethanolic potassium hydroxide solution until permanent pink color is produced. Next one, determination of saponification. Accurately weighed 1 gram of sample. Uh, Transfer into a round bottom flask. Add 20 ml of 0.5 normality potassium hydroxide solution attached to a reflux condenser. Set another reflux condenser as a blank. Everything present except the fat. Heat both flasks on a boiling water bath and for 30 minutes. Leave to cool room temperature and titrate with 0.5 molarity HCl and using phenolphthalein as an indicator until the pink color disappear. Record your reading as ml for the uh, test for blank. The picture show the procedure for saponification value. Next one, calculation. The saponification value is calculated by volume of potassium hydroxide used in ml into normality of potassium hydroxide into 56 divided by weight of oil in gram. Next one, saponification value blank titration divided by sample into normality of potassium hydroxide into 56 divided by weight of sample in gram. The sample calculation shown in the picture. And next one, significance. Saponification value also indicate the length of carbon chain of the acid present in the particular oil and fat. The magnitude of the saponification value gives idea about average molecular weight of the fat or oil. Higher the molecular weight of the fat, the smaller is its saponification value. The higher saponification value is greater than the percentage of short chain acid present in the glycerides of the oils or fats. Thank you. Next class we will see you.